Good morning, Ged.
Morning, Luke. How are you?
I'm very good, thank you. Thank you very much indeed for being on the spotlight on the Joinery Hour. We are on following on nicely from the last 4 weeks. We're now on machining and machining for prep this week. So if you don't mind, Ged, for those who don't know you, I don't know who in the world wouldn't, but if you don't mind introducing yourself, telling us a bit about your background, where you've been, where you've got to, what you're doing now for lights.
Yeah, okay. Well, for anyone who doesn't, my name's Ged Maloney. You might see Jared on my emails. Either one will do. I'm not bothered between the two. I'm National Technical Manager at Lights Tool in UK. And as such, I have responsibility for solid timber applications, which of course includes joinery, but it also includes sawmills, which is something we're going to touch on today for a few minutes. My background, I started in joinery manufacturing back in the late 14th century, it seems to me, but it was actually about 1984. And I did my apprenticeship making windows and doors and staircases, a bit of shop fitting back then. Went to college in Manchester, continued at college a little bit into my adulthood. Part of my responsibility at Lights at the moment is training and development for new recruits and people wanting to know more about the industry.
Awesome. Thank you very much indeed. So, Craig and Steve, obviously, last 4 weeks have been talking about preparation in regards to finishing. So let's talk about the surface preparation with machining. So, starting at the sawmills, could you explain the timber being planed all round at a sawmill versus maybe in a joinery shop?
Yeah, sure. And it does lead on very nicely from what Steve and Craig have been talking about over the last few weeks. And some of you may recall that we did speak about the difference between the surface preparation in a typical joinery environment, where we might be planing all round, PAR as it's known as, on a four-sider or perhaps on a planer thickness of machine. And the effect is essentially the same. I'm going to show my screen a few times here, but if I just bring up a quick image of a window frame, here we are. If we look at the blue arrows on those sections, if this timber was bought in, and some people do, directly from a sawmill, then those surfaces with the arrows against them are not going to be reworked. The outside of the frame doesn't matter, it's going up against the bricks or the timber frame, not going to be seen. And the other 3 surfaces are going to be reworked. They're going to be profiled by the tooling on the spindle moulder. Now, if the sawmill is a sawmill that's running at high speed, then the type of tooling that they use is quite different than what we might use in joinery manufacturing. If you think about a 4-side moulder, we've got a 4-side planer in joinery manufacturing. We've got some tolerances to think of. If it's got a 40mm shaft and a tool fits on it, there's got to be a tolerance between the two, or else you wouldn't be able to pull it on and off. So if you imagine looking at that shaft with a microscope, the tool, when it's at rest, will be touching at the top and it'll be missing everywhere else. What we try to do in the sawmill, again I'll share, is remove some of those tolerances, and they will use tools a little bit like this. And the central point of this tool here has grease nipples, and they are they pump up oil into the bore of the tool. And what that does is it removes the tolerance. It absolutely centralizes the tool so that when it's spinning, there are no tolerances like I've just described in the joinery environment. And what that does is the pitch marks that we can see here, it brings them closer together. So there are less tolerances. In the joinery world, whether it's a 4-wing tool or a 2-wing tool, the effect you're seeing on the timber at the bottom here is the same. It's called a one knife finish, and it's because of there are inaccuracies, and one knife will always be cutting, making the effect. So you could have 10 wings on there, you'll still see it at the same thing, at the same distance. If you use tools like this, you eliminate one of those tolerances. And then what they further do is they joint the knives. And that is the process that makes the surfaces different.
Okay, so what do you mean exactly by that jointing? Joint the knives? What? I have no idea what you're talking about, if I'm honest, Jed. So just for me,
no, this is if you buy a piece of timber from a sawmill that's running at high speed using a tool like I've just put up on the screen, they will have jointed those knives, and what they do, they set the tool running, and a stone comes in and dresses those knives, so that by the time you've done that, the knife cut is absolutely concentric. So all the knives on a tool like I've just shown you, where there might be 20 odd or 30 knives, every single one of them is having an effect on that timber. But the secondary effect, so the pitch mark distance improves, but the secondary effect is when that knife dresses those, when the stone dresses those knives, it actually dulls them, and they are pounding the fibers of the timber. It doesn't make any difference what the cell structure is, whether it's hardwood or softwood. I mean, it is pounding the surface of the timber. It comes out of the sawmill looking like glass. People call it different things, a mill glaze, mill sheen, and it looks magnificent. But the fibers are just desperate to release themselves. And what generally causes them to be able to do that is moisture, either ambient or applied by water-based coatings. So the fibers rejoin us, resurface, and it means sanding. So it may be that you can't do anything about buying your dimension timber in from a sawmill, but it's important that we understand that those surfaces that I showed in the first picture are going to react differently to coatings than the ones that have been profiled on the spindle molder.
So if you're buying, my brain is saying, well, okay, so you're buying those in from a sawmill. Surely, if you're slightly oversized, would you you would then machine that timber in-house to get rid of that compounded effect?
Yes, that's absolutely right. And the timbers that we recommend from our suppliers within the joinery network is supplied marginally oversized. And I recommend that if you can, say it's 5 or 6 millimeters oversized, which is 3 off every surface, is the right process to go through.
Right. Okay. So can you just explain? You mentioned pitch marks. Can you explain exactly what you mean?
The pitch marks, people may know them as different terminology in the country. Just let me share again. It's the effect. There's the image of joint, and it's a German word for it on there, but that's what the jointing looks like on the machine. So as the tool is running, before the timber goes through, that stone trims the edge of the stones off. Yeah, the pitch marks, this is what I'm talking about with pitch marks. If you imagine the timber as you look at your screen moving from right to left, these pitch marks are the effect of the knife. So at the coarse end, where it's 5 millimeters apart on timbers that don't matter. So an example of that might be framing timber where dimensions are important, but the surface finish is not. Then we slow the feed down, got down to the area where we're talking about fine. That is the area we're looking at in joinery, between 1.3 and 1.7 millimeters apart. But the consequence of that on the tool is that wear increases, and that's simply because the tool's touching the timber more often as it goes through, because the timber's not moving as quickly. So that's the effect of the knives on the screen. On the knife.
Excellent. And what about the different planing solutions on the market, Jed? What is what's out there? How do you manage this, and what should you be using, or is there any recommendations as well?
It also was touched on while Craig and Steve were doing a presentation on the application of paints, that you can you often find on the market helical design, like so. That's the lights version of it. We call it Heliplan. Are absolutely fantastic tools. Run very quietly. They can remove a lot of material and they last for ages. And the great thing is about them, if you do pick up a snick but off a stone or a staple, you've only got one knife to spin round and it's got 4 edges. There are others on the market too, and they all have a similar spiral helical cut. But the disadvantage is, no matter how good the seating is for those knives, or in the case of lights, the outside of the knives is slightly convex, so the overlap is less visible. Nevertheless, it's always visible, and certainly when you apply water-based coatings. If you want a finished cut, a full knife all the way across is the best option. And there are plenty already fitted to machines, running from old traditional 30 millimeter type knives, where they just taken out, resharpened and repositioned. Yeah, someone's job for a Saturday morning, I reckon it takes. It's an absolute nuisance. Or there's some like this one and others on the market that are reversible knives, and they're much easier to change. That's one of those will give you the best finish in the joinery workshop.
So is that your recommendation? Is what did you call it, a full knife?
The full knife across is the best recommendation, and that the image of that tool is our best. We have several planing systems, and that is the best of them. We'll come to the reason why in a few minutes.
Okay, so parameters and speeds. What considerations are there on parameters and speeds? I hear lots of people talking about this, and since I've had a relationship with lights, which is a fair few years now, it is more important than most people can understand, in my view.
Yeah, the pitch marks that we talked about, there are 3 real considerations that have an effect on that. It's how fast the tool is spinning, the diameter of the tool, and how quickly you're feeding the workpiece through. Now, I'm not going to bring calculations up. These calculations are widely available. And I stress they're not lights calculations. These are scientific calculations that lights uses. There's obviously pi involved, Luke, which will light your little eyes up, because I know you like steak and ale. But I'm not talking about that pi. I'm talking about the one that's short for periphery in Greek, that symbol. But one thing that often surprises me that people don't realize is, if the spindle is spinning at 6,000, and many of the 4-side planing machines in our industry are, and your tool is 125. Again, that is absolutely typical. Then the cutting speed that generates, the peripheral speed around that tool, is below the lowest of acceptable speeds. The meters per second speed, I don't want to go into the calculations, is lower than the lowest acceptable, and nearly half what is good. So the finished cut from something like that is never under any circumstances going to be the best you're going to get. So it's not my role to advise about certain machinery manufacturers, but it is to advise about the features of the machine. And we often talk about getting motors with a higher RPM. So, for example, when I say this, it will become obvious, but it's not always immediately obvious. If the spindle is spinning at 6,000, as I said, and your tool is 125 millimeters in diameter, if you make that tool twice as big, it'll be traveling twice as fast around the outside. Or if you leave the tool size the same and spin the spindle twice as fast, it will be moving twice as fast. So the bigger the tool, the quicker the peripheral speed. These are the parameters that we need to think about. But I would go above 90% of machines in our industry are running at that speed where finish will be suboptimal, and that's a euphemism.
So why, if over 90% of the machines available in the market are under par, let's say, why are we accepting that? Is it just because a lack of understanding, education? Because what is the optimum speed? What should it be traveling at?
Well, if that tool is 125 millimeters, that is the more common element of it.
Sure.
If it was an 8,000 RPM motor, it would be cutting at a more acceptable speed. It'd be more like 60 meters a second. But not, you can't retrofit them. But if I was buying a new one, I'd be saying, can I have motors? How big are my planing tools? And if they're 125, do a calculation and say, would it be possible to have a motor that runs at 8,000?
8,000, right? Okay, there you go. I'm learning a lot this morning, Jed. So,
I hope so.
Yeah, well, it's not difficult, is it? Come on. So, sharpening. Obviously, Lights offers a fantastic sharpening service, but talk to me about how that affects the surface quality and also when you should be looking to change. Because again, people do have a lot of their knives sharpened, but they run them into the ground, and then when they get them sharpened, it's obviously a much bigger job and costs them more money if they're not doing it at the right time. So just unpick that for me, please.
Yes, my colleagues in the servicing, sharpening divisions of our company would never forgive me if I didn't mention this, but there are some serious considerations. There's a few things. If you just take sharpening traditional planer knives, the type that I mentioned before, where they're 3 millimeters thick by 30 millimeters, the way that they're sharpened, a grinding wheel spins horizontally and skims across the top, and the knives are positioned at the correct angle. And you can feed that machine pretty quickly, and you can grind it very hard, very heavy, if you like. But the effect of that is that the knife won't last long. So if it costs, let's just say, a tenner to sharpen a pair of knives, and you'll find it on the market for £6. And the way that the company is not going out of business by doing it is by feeding this machine very quickly and grinding the wear out in fewer passes. The drawback of that is when you look at those knives microscopically, the edge that's created looks like a handsaw, and that it's the top of those V shapes that dulls first, and the closer those V's are together, i.e. the lighter the grind and the slower the feed, the longer the tool life. So the cheap sharpen means it's often going to be back off the machine very quickly again soon. The other thing, and this is a way of testing, if it's a quite a long knife, any machinists will have on a surface planer may have experienced this, where you're trying to set the tool, and what you find is that the knife is not in a straight line. It's either concave or convex, and it's a giveaway for heavy grinding. And it's the bottom of the knife is still perfectly flat when you put it on a straight edge, but the top of it is either convex or concave. And this is an absolute nightmare for anybody trying to set it up. And anyone that has done will know exactly what I'm talking about. Again, it's an indication of cost cutting, compromising, call it what you like. I just put an image up of the wear on some planing knives. 1 second. The image on the left is an HS knife with what would be an acceptable amount of wear, having planed, and what we're talking about there, that amount of wear that we would have to remove is about 0.3 of a millimeter, 0.2, 0.3. The knife on the right is a marathon coated HS steel knife, having done the same amount of work. And you can see that much more, it's not ready for sharpening yet, that one. So something that you can do to avoid having to change those knives is to use what we call a marathon coating, and it's a secret recipe. It's a KFC job that's applied to the surface of the knife here, and so when it's sharpened on this surface here, the effect of it is still you're still gaining from the effect of it. So there are considerations when you're talking about servicing the knives. At this point, I did mention that the best recommendation for planing, we call it Vari-Plan. This is when I talk about it being a difficulty for machinists setting up the old-fashioned knives, the ones I mentioned where it's indexed, where it's just you turn the knives over, they keep your diameter at 125. Excuse me. So it means that there's no reprogramming the machine in any way. So that is a real advantage. The advantage of Vari-Plan is it's constant diameter, so you've got that advantage. But those knives are resharpenable, so they can be turned round. They're resharpenable on the face, and they index back up to a datum, so they keep going back to the same place. So it's 125 when they're new, and it's 125 when they've been sharpened 3 or 4 times. That's why they are a very good value, easy to set up. That's why it's the best recommendation.
Cool. So that is, I think, planing and like machine prep, if you like, pretty much covered for now. Next week, we're moving on to profiling. Can you just give us a little bit of a clue how those two complement each other, and maybe a little bit of an insight what's to come next week?
Yeah, sure. I'm going to concentrate next week on the tools that we supply for the Lignum range of products, and the way that we use those on a spindle molder or other machines indeed, and the design of those and why, and the effect, the great effect it has on the timber, why the knife finish is better than sanding in many cases, not denibbing. It was important that Steve and Craig pointed out over the last few weeks the difference between sanding and denibbing. Denibbing is a necessary process, and sanding often unnecessary. I'm just going to touch on profiling because some of the processes that we do with the Lignum products can be done on machines. Just looking at the chat.
By all means, answer away if you've got the answer.
I'll come back to those in a minute, Jim, if you don't mind. I've only got a couple of minutes yet. Yeah, what I wanted to just show you was that some of the processes can be done at once on one spindle using a profiling system where, and just show you an image of it, it'd be a lot easier. This tool looks like it's got 4 wings. In actual fact, it's got 2 plus 2. It's a planing system here, vari-plan knives here and here. And what we can insert here is profiling knives, which are again indexed so that the relationship between the planing surface and the radius is always the same. So with this section, I know it's not a section we use, but it's an example from our lexicon.
Sure.
We've got a situation where we could profile just at the bottom, profile just at the top, top and bottom, or neither, and just plain. So an example I often use for this is a torus skirting. If you imagine a torus skirting board mold, the flat surface of the skirting board will be planed by the planing knife, so it doesn't matter how wide it is. Be doing it from the top in that case. And the relationship between the mold and the surface, so that if the deepest point of the mold was 10 millimeters when it was new, it would remain 10 millimeters throughout the knife of the lives. So that's just to give you an idea. Through feed machines like this would be good for things like sill sections and for rain-head plantons. That's the type of application where these type of tools have been used by many people within the network. I know several who are already using it, so it's consideration for you.
Awesome. Do you want to quickly answer Jim?
Yeah, just let me read through them.
Read it out loud so people know what you're answering.
I've skipped off it. Jim. Waterborne, of course they are. Yeah, we touched on it over the last thing. In your first one, they're not water-based coatings. This is a question from Jim Rooney. If you can't see the chat, they're not water-based coatings. They're waterborne. Yes, you're quite right. Your terminology is right. Treating with waterborne preservative prior to assembly and cleaning up reduces furring dramatically. Yet the application of those things, the correct order of that, had been covered by Craig and Steve quite extensively over the last few weeks. Sanders are the only machines that finish timber. We'll move on to the knife finish next week with our profiling, which the surface of which is made worse by sanding. And as helical planer blocks have a reasonable finish and produce more extractable chippings, they can even cope with sycamore, maple, beech. Traditional parallel cutters produce full width chippings that easily block extraction systems. Yes, there are advantages and disadvantages with the helical cutting, and in a sawmill where you've got multi spindles, the ideal situation is to remove the bulk of the material with a helical type tool and then finish by taking off a tiny amount, say 0.5 with a full knife. That would give you an ideal situation, but that does not tend to be, it's not possible in joinery manufacturing very often. You've got a very sophisticated machine if that's the case. There's absolutely nothing wrong with any of the helical cutters. They have great advantages. They draw less amps. They run more quietly. They don't have to be changed as often. Yes, they have all those advantages, but I stress those shadow lines are visible. They might not be visible when you first cut it. They might not be visible to the man or woman in the street, but as soon as you wet them, they are.
Excellent. Well, we'll go back to the floor in a minute, and I'm sure the conversation will carry on. Thank you very much, Ged. Or the only thing I've got left to ask you is, I think an explanation of Alfonso the Dancer is required, mate.
Well, it's taken you about 30 minutes to get to that, hasn't it? And I expected it in the first 10 seconds. Well, I did anticipate you asking why. You don't get a name like Alfonso the Dancer for nothing, let me put it that way. And in order to try and get people to stay with us for next week, I think I'll tell you next week.
Oh, it's the hook. The hook. Love it. All right, let's go back to the floor. Thank you, Jed.